Hello, everybody. Good morning, afternoon, evening, wherever you are. I am Greg Loeffler, and I'm here with Jonathan Campos, and we are going to be talking to you for this hour about OpenTelemetry and observability. So I will give you a brief introduction about myself, and then we'll have Jonathan do the same. Then we'll jump into it. If you have questions, comments, feedback, please give it to us in chat. We'd love to be able to address those things as they come up. If you were attending .conf with us and you saw the observability super session, you may have some questions from that we'll try to answer too. Jonathan and I both are observability practitioners at Splunk. What that means is that we are technically in marketing, but the stream is still really early, so hopefully not everybody hears that. What we're responsible for is for making sure that people understand sort of what observability is, why you need observability, and how you can get there. And both of us were DevOps people in a past life. I was an SRE at LinkedIn and at eBay Advertising for quite some time. And I'll let Jonathan introduce himself and tell you about his background.
Thanks, Greg. And I'm Jonathan Campos, everyone. I was a DevOps engineer for Citrix for about 5 years. Have a lot of experience in IT ops and DevOps, and definitely understand a lot of your pain points when it comes to just monitoring and observability and really just getting up in the middle of the night, taking an alert and not necessarily knowing what to do with it. We've both been there. And let me just say, there's not enough coffee in the world that can always make that experience pleasant. Been with Splunk for about a year and really happy to be here to talk to you guys more about observability.
Yeah, I think before we really dive into what observability is, I wanted us to sort of set the context for why you need it. And one of the things that really is a driver for observability is the fact that just managing modern applications is kind of a train wreck when you think about compared to how applications used to be. Right now, everybody's moving to a microservice model, and there's a few reasons for that. But one of them is, developers prefer microservices because you get to use your own pet language and framework, and it doesn't really affect anybody else too much as long as your APIs are stable and you've done the work on the back end. And operations, really we kind of like them too, right? There's a smaller failure surface. There's not as many things that can go wrong with each individual service. But when something does go wrong, right, we're not looking at a 3-tier infrastructure, right? We have a murder mystery of it was service X with dependency Y, with downstream Z are all sort of things that we have to try to figure out. So figuring out where the problem is and how something went wrong is really kind of a pain. So, the microservices migration has some perks, of course, but there's a lot of problems. And Jonathan, if you want to give some feedback on what you see there, what are the sort of problems people see when they move to this cloud migration or are adopting microservices? What are some of the problems people run into?
Well, the first question that I have to ask myself is where is it and where did it come from? In a monolithic approach, we have the server, we have the client, we obviously know where to look. But in distributed microservices architectures, you may have a service that may be your cart service, a service that may be your Redis service, a service that may be your front end service. And with this distribution of services creating this one beautiful, elaborate application or website or whichever deployment you'd like, well, with respect to your organization, you have to factor in that now you have a lot of potential needles in potential different haystacks to look through. So having a clear and concise cookie cutter view of where things may be going on and how things are working together is really where I think observability has come to really help the DevOps and SRE community.
Yeah, I think one of the things that is really challenging is figuring out where problems are, like you said. In a microservice model, everything's loosely coupled. And so there can be interactions that you may not expect, you may not even be aware of, right? Like if somebody else writes a service that starts calling your service can fall over based on the extra volume. You had no clue that that was going to be a thing, right? So, there's that. But then there's also, like, I wanted to briefly talk about that getting the benefits of the cloud migration. Like everybody's talking about, we got to go to the cloud, we got to do the cloud. Why, right? And well, one of the reasons you go is for auto scaling. and we don't have to buy hardware anymore, right? Amazon buys all the hardware for us, so that's great, and that's true, right? But if you want to be able to take advantage of those benefits, you have to re-architect your application into these smaller microservice models, right? There's not really a cost-effective way to run old school monoliths in the cloud. So as people start to do these migrations, right, they adopt microservices, and it causes us problems, right? And why some of those problems happen? Well, too much traffic is the famous one, right?
And how
Either
about code changes? How about code changes as well, right?
yeah,
How can we
right. I mean,
on those different code changes that are just coming in with different languages for for developers that prefer to code in X, Y, or Z language? And it's okay as long as, again, to your point, your APIs are stable and you did all the work in the back end, everything's good to go. But we have to also keep up with those code changes. And I know that in some cases we get that small little minuscule character that's just in that wrong place to break things, right? Like thinking of a potential access token that could prevent one API from talking to another, right? Something as small as that.
well, and it's also, I always used to joke that my job at LinkedIn was being a professional fighter against change, right? It's like if we don't change anything, nothing's going to break, right? Because we've got it working now, so it's fine. But obviously, your business can't stay stagnant forever, so there's going to be code changes. You have to change the code, right? And there's also, your dependencies could have problems if you're running stuff in Node and the whole left pad debacle happens, right? And you choose that time to redeploy your service. Well, now it's not going to deploy because there's problems with npm, right? Like there's so many possible failure causes, and I think the real takeaway is that there are so many more than there were before, when you had a simpler architecture, right? Like it may not have been as robust or as cool to work on, but you could pretty easily figure out where the problem was. There are only a couple of options, right? And in even a relatively simple site, we use a thing that we call the hipster shop here, and it's built
Yep.
on like 17 containers, right? And it's a very, very simple, put this in your cart and check out with it thing. So anything of any complexity, LinkedIn is probably by now in the multiple thousands of services that make up that site. And finding the problem is a huge deal.
So, Greg, I think I want to ask you a question for our audience, right? Just based on your experience, having this, just actually, let's take a step back. How would you describe distributed tracing, and
Yeah,
how would it have helped you back with LinkedIn and eBay in all of those microservices?
yeah. At eBay, they didn't have anything at that level of technology, and at our division, of course, it was relatively straightforward. The challenge at eBay advertising was real time. We were running an RTB ad buying service, so if you don't respond in 400 milliseconds, then too bad, right? You lost the opportunity. So it wouldn't have helped us too much there. But at LinkedIn, they do have a distributed tracing tool that they built in house, of course, like everything else at LinkedIn, right? It was, they had the scale to justify building your own tools. But before that was ready, figuring out where the problem was generally was like the old school nightmare of the SRE phone tree. It's like, okay, well, my service is the one that had the proximate error, so I got paged. And I go and look, and my service looks fine. So let me see what my upstreams are, and let me call them and say, hey, is there anything wrong with your service, right? So, the distributed tracing, just to step back for a second, right, is basically just attaching an ID to every request made throughout your infrastructure that you can then go back later and correlate, right? So if you didn't know that, now you know what that is. And the reason that you want to have that is so that you can go see, okay, hey, where did this transaction go, right? Which services did it touch? What were the results of every single one of those calls? And to be able to see that all in one place, right? I can't tail 1700 logs at the same time and try to find something, right? I need to be able to see, all right, I know that the failing request had this trace ID, so show me everything that happened with that trace ID. And yeah, I mean, it's night and day troubleshooting, right? It's like you're not
Exactly.
really troubleshooting at all anymore, right? It's like it's just telling you, hey, here's the problem. So it almost takes some of the fun out of it, right? Because you get
Yeah.
the right there, right?
Well, The other thing that I love about distributed tracing, and specifically associating like some type of a visualization platform, is really also understanding the new downtime. And what's that new downtime? It's latency, right? When we take a look at latency, we don't want to have that at all, right? Our customers are going to understand that there are other competitors out there. We look at Lyft, we look at Uber, we look at DoorDash, we look at Uber Eats, we look at Grubhub. And if one service is not performing correctly, we can easily go to another service. So we can easily say that latency is absolutely the new downtime. And this is one thing that was benefiting me as an SRE when I was at Citrix, is just really understanding latency of the performance of the services that we were actually delivering to our cloud customers. So I have to honestly say that distributed tracing has really, really helped me, and having everything tracked with a specific trace. And just to kind of dig a little deeper with respect to tracing, is that every single span was associated with a trace ID. And I'm going to show that here in a demo a little later in our presentation. But having that and just actually seeing the entire stack end to end, again, Greg, I have to say, almost just made it too easy. And then the cool thing is you can also associate certain automation tasks to be a part of these things as you start to kind of understand these trends, right? You almost just kind of automate your way out of troubleshooting, which is a beautiful thing, allowing you to really, as an SRE, continue to innovate and continue to just enjoy, right, some of the fun parts of your job, as opposed to necessarily just going bonkers and kind of on an alert storm, right?
Yeah,
So
there's fun in troubleshooting for sure. I mean, if you don't enjoy
absolutely.
troubleshooting, like the SRE job is not the job for you, right? But it's not, you can't troubleshoot all the time, right? You do have, there's a lot of things that we're required to do, like capacity plan and do architecture, and to figure out, what's the right way to design this service that you want to roll out, right? So like for a lot of people, that's the fun part of being an SRE. And the troubleshooting is sort of a must do, not a want to do, to your point, right?
Yep. And let's not also forget the cost analysis as well, right? So cost analysis was a big thing for management, for me, reporting on that information and being able to again understand that capacity to cost ratio was important. Greg, I'm going to just throw out another question here for the audience, and I got to ask, what about OpenTelemetry and the observability journey? How can you elaborate a little bit, or we should potentially elaborate a little bit about what really OpenTelemetry has done in the whole observability journey? What are your thoughts on
Yeah,
that?
I think that's a good place. Before we go there, I do just really quickly want to say, like, everybody talks about cost, and it's definitely an important thing. And the real like catch with doing a cloud migration to save
Mhm.
money is, you do have to re-architect your service. If you think about, hey, I'm going to take my existing service and I'm just going to put it in the cloud, and it's going to need the same hardware that I had, the same network that I had, the same power that I had, the same systems administrators that I had, all of that is going to be the same. Plus, Amazon, Google, Azure has to make money. Like,
That's
there's
right.
no way it's going to be cheaper, right, to put it in the cloud unless you make those changes. So I think, it's just, like you said, slow is the new down. And with this expansion of infrastructure in the cloud, the costs can expand really quickly if you're not careful about it. So observability tools can help you monitor costs and keep track of costs. It's not something we were planning on talking about today, but if you Google it, we've written some articles about saving money with observability, but
Absolutely.
it's something that I think is important. But yeah, OpenTelemetry is really, to me, it's, if you're going to implement observability, you're going to have to do some work, no matter where you buy it from or what you're doing. You're going to have to do some instrumentation for your applications. You're going to have to run some process that gets data from all of your infrastructure. All that stuff needs to happen. And OpenTelemetry is really a great way to sort of only do that work and that pain one time, right? So no matter where you end up going in your observability journey, if you start with OpenTelemetry, then you're on the right footing, right? And you won't have to duplicate any of that stuff. So, to talk a little bit about OpenTelemetry itself, right, we go back to Open Tracing and Open Census, which were, telemetry projects and not telemetry in like the scary EFF consumer way, right? But telemetry in the internal business way, where you need to know what your stuff is doing. And so those two projects merged and became OpenTelemetry, and it's now a very hot product. It's the second most popular
Definitely.
CNCF product. It's only behind Kubernetes itself, right? And there are tons of contributors, right? It's not a Splunk product; it is a community product. That, of course, we happen to contribute a lot to, but that's because we have an interest in making this the best telemetry system, because that's the one that we use. But it also helps you with sort of getting an understanding of what the data pipeline looks like for your telemetry, right? You do have to spend a little bit of time being intentional about where does this data come from, what do I do to it, and where do I send it, so that you sort of understand where your telemetry data is going, right? If you install some third-party agents, it's just, oh, run this command on your box and magically everything works. Well, that's great, but I feel like the kind of people who use these products to get into these products don't really like magic solutions, right? You want to understand what it's doing, you want to understand how it's working, and you want to have control over it. Right? Fundamentally, this data is key to your business, right? These metrics, what's going on, how long they're taking, where there are problems, how many customers you have, like all of that stuff is essential data, and giving up control of it to some random party, right, and not being able to control what you send and how you send them is a huge deal. So, like, I think the biggest strength of OpenTelemetry is, you instrument one time and you're done. And then the second biggest strength is you maintain control over where your data is going, how you process it, what you do with it. And there's a whole community of people you can talk to, right? You don't have to rely on your vendor support person who, probably has hundreds of other people they're trying to fix, right? Like, you can go to GitHub and post to the issue and say, like, hey, I don't know how this works, or fix it yourself and send us a PR, right? And then you can change it. So, like, it's just really important, I think, to make sure that people know they have control and agency over their telemetry data. It's really valuable. It's really important. And so that was a really long way to answer that question. But I think OpenTelemetry is probably one of the most essential products that we sell, and we don't even sell it, right? It's because it really is telling our customers and the whole community, like, we want everybody to have observability, right? That's why this is open source. That's why you don't have to pay us for it. And obviously, if you use our product, we feel like you'll have the best implementation. But the observability community in general is better off when there is a high quality open source ecosystem there. So I think that's part of the value of it as well. Is it's not just something that you can only use here. Like, we can export to anything you can imagine. Our native data source is OpenTelemetry, right? There's no adapters. You don't have to figure out, how do I map this into Splunk? Like, that's just what it is. So I think those are all really important things about OpenTelemetry.
Yeah, and those are all great points, Greg. I have to say, really, just having the ability of just becoming vendor agnostic with all of my instrumentation throughout all of my applications just really gives me the peace of mind that I am in control. I am in control. And whatever I want to instrument that's best for me and my organization is obviously going to be best for all of my SREs and so on. So, and then this brings me to another topic which comes with cardinality, right? When we start to look at data that has high levels of cardinality, when we think of like usernames or account IDs, and how it really helps with observability and really finding your problems within your environment, right? Say you want to narrow things down to a specific user or a specific account ID, you can really do that. And it's all about really leveraging your high cardinality metrics, right? When we think about, for an example, your environment, which data center is this problem occurring in? Or which deployment is this environment occurring in? When we think about blue-green deployments, is it in the green deployment or is it in the blue deployment? Right? What version? These high cardinality metrics really, really help. Any opinion on that?
Yeah, I mean, it's really one of the things that I think, it's kind of it's sort of difficult to explain. I think because we use this term cardinality, that's a math term and like an advanced math term, instead of just saying, like, hey, it's about slicing and dicing and filtering, right? That's really enriching your data so that you can decide later on, hey, I needed to know at the time this transaction happened, right? Like, was this user ID that is a high value user, right? Or are they a first time customer? Or, what sort of environment is this happening in? Like you said, right? In
Hmm.
uh, LinkedIn was an owned and operated environment, so every host was named with the physical location it was in at the beginning of it, right? So, okay, we don't really need a tag for that. We can pretty much see, but LinkedIn now, due to some M&A activity, from what I understand, is now hosted on Azure, where your host names, do not necessarily contain all of that infrastructure information, right? So, if the host name for your host is app7649386, and you're like, well, okay, where is that? What is
Yeah.
he in? What is, even what type of machine is it, right? And
Yep.
I think, one of the problems that can happen a lot to cloud companies is you're like, okay, well, I have this one service I run that needs some really beefy hardware, and it's image resizing or video transcoding or something like that, right?
Hmm.
And if you make some changes to your Terraform config, or to something like that, and you accidentally deploy that on an X2 micro, it needs to be on a 4x large, right? Well, it's not going to work, but being able to see right away, oh, hey, this is the wrong instance type, is really valuable. But even
Absolutely.
even beyond that, if you're thinking about like, okay, how do we solve these problems and how do we make this better for everybody involved, right? You
Mhm.
need to be able to enrich your question answering ability, right, with this stuff, right? So it's not enough to just say, oh, it was this service on this host, right? You need to be able to see for each transaction who was doing it, what were they trying to do? And you can even enrich it with things like, hey, this customer came in from this particular marketing campaign, right? And so you can use your observability tools to figure out that kind of stuff, right? It's not necessarily like a documented use case. We don't have an example for that on the
Yeah.
website, right? But it's something that you can do, and I think the real value here is just, as anybody that does this knows, the more data you have, the better, right? And the more things you can analyze, the more
Absolutely.
things you can slice, the better off you're going to be. And you really want to try to pick a platform that's not going to limit you into saying, hey, well, your tags can have 4 different values, and that should be plenty, right? Because that's not going to be plenty, right? You need to be able to have, I mean, I would argue you have to be able to have infinite cardinality to really get value out of APM, because a lot of the speed benefits to troubleshooting are, hey, the CEO said when he came here, this thing broke. And I'm like, all right, well, the CEO's user ID is, and let's see what those
Yep.
requests were, right? I mean, I can't tell you how many times at LinkedIn with our old CEO, he would encounter some one-off thing and fire off a thread to SRE at, and then, well, now we're digging into the rest of the universe to try to figure out what was going on, right? And it was especially challenging because, his account obviously didn't have any of the limits we put on other accounts for performance and that sort of thing. So, he could have like 400,000 connections, and he does some graph operation that we're not thinking about, and boom, there goes the whole site, right? Because they're trying to operate at 400,000 people at a time. So, if we had had that ability to tag those requests and visualize them sort of in real time, it would have been faster, right? I can still tell you our old CEO's user ID off the top of my head because, that's where you're going to go find those problems, right?
Yes.
Um, but having that would have helped a
Same
lot.
here. And the other thing is just really getting to that quick MTTR, or is just really key. But one thing that came to mind is, do you think there is a hidden cost to sampling when it
Oh,
comes to having high cardinality? Do you think there is?
oh gosh. I mean, I I will argue all day that sampling is a huge miss, right? Yes, I understand data storage and ingest can be expensive,
Mhm.
and depending on your platform, there's some things you don't want to send all the data to. But the real challenge is at the time you ingest the data, you don't know that it's going to be something you need to look at later, right? If you could do that,
Exactly.
then you wouldn't need an observability platform, right? Like
Yep.
if you know at the time the event happens that this is important, then just fix it then. What you really need is something that can say, hey, we save all the data for at least some amount of time, so that when a problem happens that is some weird problem, and let's be real, they're all weird problems, right? We don't keep services running that have regular persistent problems, right? We fix them. So, every time a problem comes up, it's like, oh, well, that only happens one out of every, million times. Well, but that's the time you care about, right? So, if you're doing sampling and, a lot of people have tried to come up with ways around this where, they'll ingest all the data and then immediately delete all of it except for, things that they think are interesting or whatever. But like, to me, an algorithm cannot fundamentally tell, hey, this is something you're going to care about later, right? It's just you
I
can't
agree.
guarantee that's going to be the case, right? So I would argue people will say, oh, sampling makes it cheaper because you send us less data and we store less data, so we can save you money. But having an outage go on another 10 minutes because you couldn't track down, because the first time it happened, the trace got thrown away, right? Well, how much is that 10 minutes worth of downtime, right? And I'm sure I can find some analyst that says downtime is $800,000 a second or whatever, but like for your own business, how much downtime costs, right? And
Oh,
so like that one time that trace got missed because of sampling, probably the time you really care about it, right? So I would say sampling is a critical error. Like you can't do it and really continue to get the benefits from observability.
I cannot agree more. I cannot agree more. I can't tell you how many times I've been in that situation myself where something happens, but we don't know why. And then we as SREs just say, you know what, just reboot it. Reboot it.
Yeah.
And we reboot it. And then yeah, things start to work again, but we don't know why. And then my manager will come in and say, well, hey, what's the RCA for that? Can't really put, well, I rebooted it and it worked. You
I mean,
know?
I can't tell you how many postmortems I've been in where the outcome was, well, we rebooted it and it didn't come back,
Oh,
so we must have fixed it, right?
we're just going to
I
keep
do.
rebooting it. That's what we're going to do.
Right. I mean, well, and a side note is like auto remediation is like this super popular topic and has been for a long time. But
Absolutely.
I mean, I don't know. To me, if you can anticipate a problem and anticipate the solution well enough to write meaningful auto remediation, just fix whatever's causing the problem, right? Like, all of the auto remediation that I've seen is, oh, we'll restart the service. And okay, well, I mean, that's a really big pastiche over a lot of problems, right? If you have some memory leak, right? Like, one of the things that I really liked about LinkedIn was there was a shutdown around Christmas, and it was a
Hmm.
week and a half to 2 weeks, where the company was shut down, and even before that, changes weren't going to happen a lot, right? People were getting ready for the break. There wasn't a lot going on, but we discovered a lot of memory leaks and stuff like that for an application that ran untouched over to, because normally we were deploying every day, right? Or a few times a day. So, for apps that ran for a week, we would discover very quickly, oh, hey, this Java app has a memory problem. Who would have guessed, right? So, hey, we have to write auto remediation that restarts the service, which again isn't really fixing the problem, right? It's putting a band-aid on an axe wound. Like, okay, well, there's not as much blood coming out, but like the problem is still there. So, I want to make sure you have time for your demo.
Yeah.
So
Yeah.
while Jonathan's getting that together, like we put together sort of an overview of what observability can do for you, like what you see, what it actually looks like, that Jonathan's going to show us using some little example microservice. But the same principles work for a really huge installation, right? We can take basically arbitrary scale. We have customers that send us petabytes worth of data a second, right? Like we can handle a
Yep.
lot of data. So, the real value here is in seeing sort of what this platform does for you. So Jonathan's going to take us through that, and I'll, chip in with peanut gallery comments as he goes along.
And thanks so much, Greg. I do appreciate it. So let me just move this screen over here so I have that in the right place. And I think you guys are seeing VS Code on my screen here. Greg, is that right? You able to
Yeah,
see
that's what's
that?
on there. Yeah.
Awesome, awesome. So here's what I did. I have a small little microservice application that I put together, and what I did here was actually auto instrument it with OpenTelemetry, and just installed obviously the necessary dependencies that we needed. It's a small little movie database. I know that some of you guys may not be big fans of these movies. I was a big fan of Jurassic Park and Jaws. I gotta say. Um, I got the idea from Annie, from my wife. I was like, I need a list of movies, quick. So got that, looked up their directors as well as some of the actors that were associated with these movies. So this simple microservices application is what we're going to use as part of this demonstration for this sandbox machine that I actually have here. But before we get started with that, I do want to show you guys how simple it is with Splunk Observability Cloud to get started with infrastructure monitoring and get started with monitoring your Kubernetes cluster. And we'll take a look at some of the different components that the infrastructure monitoring tool allows us to see with respect to our hosts or our Kubernetes cluster. Starting with the data setup process, as you can see here from the data setup process, we have a very nifty wizard-like area that we can use to connect our data. And if we want to choose Kubernetes, we can choose, of course, or if we want to install Kubernetes, we can select Kubernetes, or we can, of course, select Linux or Windows and so on and so forth. And of course, we also support the three major cloud platforms, as you may already know. When it comes to Linux, you can see that the process is rather simple. This is exactly what I have installed on this host machine here, where you'll run a small curl command and you can quickly restart the service if in the event that you are going to change the configuration. And you can see here from this sandbox machine that I'm running, if we run a quick service Splunk OTel collector status, you'll see that this particular collector is installed and is absolutely receiving data from my microservices application. So that's cool. Just wanted to show you guys that, in a few seconds, you can quickly get started with monitoring Linux or your Windows environment. And you can also leverage Ansible and Puppet to, of course, deploy these particular collectors using the Splunk Observability Cloud OTel collector. So with that, I also want to kind of show you guys the Kubernetes installation, which is also rather simple. And here we're actually using a Helm chart to get the installation going. So we'll just name this cluster test for now, since I won't be installing the actual collector rather itself, but just showing you the process. We're actually leveraging Helm. So of course, with Helm charts, things become very easy with Kubernetes. We'll add the repository. We'll go ahead and update all our repositories, and then we'll simply go ahead and copy this line of code here, which is a simple Helm install command. And you can quickly see that you just pretty much paste that and your installation is complete. Now, for the sake of time, I'm actually just going to show you guys what that looks like. So if we do a kubectl get pods, you'll see that the actual collector has been installed and has been rebooting for quite a bit because we were doing some testing in this particular environment. And you can also do Helm list to actually see your installation. And I made a couple of revisions, I'm not going to lie, for this particular test, just to kind of show you guys some quick and easy examples of what it looks like within Splunk Observability Cloud, just for demo purposes. All right, so now that we're installed, of course, theoretically, let me show you guys what the actual host looks like. So you can see here in the past 3 hours, or we can of course filter out through the last 15 minutes if we'd like, some of our great metrics with respect to our host. And again, I want to stress that this particular host is what's running our movie database here. And you can see that we have one host. We can see some CPU metrics. We can, of course, see total memory used, disk ops, a lot of the different metrics that, of course, are very, very useful in enabling us to really see what's going on with our particular workloads. And then the beautiful thing about this is that we can, of course, change this dynamic chart and actually color by memory utilization, disk summary utilization, network, and so on and so forth. Say we want to go ahead and just show memory utilization. This chart up here is dynamic. So it's going to change based on the utilization of your environment. If we move over to Kubernetes, and I'm going to show you guys what this is exactly running in just a minute, this is a lot more intuitive. And the reason it's a lot more intuitive is because all of these workloads these pods specifically are very ephemeral. And what that means is that we're going to consistently change them. Greg, keep me honest here. You said at LinkedIn you were doing about 1 to 2 deployments a day.
I mean, more than that for some services, yeah, but pretty much everything would get pushed out, at least once a day.
So with that being said, that obviously means that you're going to have, of course, the same workloads, but you're going to have different nodes that are going to be, I'm sorry, different pods rather, that are going to be running in this environment. And that makes this, of course, this environment very, very, very temporary. So you definitely want to have the metrics that you need. And the cool thing about this particular map here is this is what we call the Kubernetes cluster map. This is a very dynamic map as well. And on the right hand side, you'll see here that you have all of the relevant information that you need in a simple overview. And I'm not sure if my analyzer is going to populate here because we haven't been running this particular cluster for some time. We just installed it for demo purposes, but you'll see that the actual Kubernetes analyzer is going to even provide you with some suggested filters in the event that you may have high CPU for one of your given workloads, or if your particular node itself has high levels of CPU. So all of these here just kind of break down a simple overview of exactly what you need to really find the problem and just get right to it. And
Yeah.
you'll see that you have, go ahead, Greg.
Yeah, I mean, just a lot of people that adopt Kubernetes do it because Google does it, so it's cool and trendy. But it's really complicated to understand how everything works behind the scenes. So I think it's just really important to know that in this example, it's running on one host because it's a Minikube install, and we don't necessarily have a giant fleet of test machines, but like in
Right.
the real world, this is going to be on thousands of instances that you need to have quick insight into what's going on. So, the ability for it to automatically notice, hey, these nodes have high memory usage or high IOPS or whatever, is something that can really help you make some sense out of Kubernetes. If you're choosing to adopt it for hipster purposes, like you really need a tool like this to understand what's going on.
Absolutely. And let's actually take a look at this particular deployment a little deeper, talking about that hipster store. And this is our APM product. And particularly in Splunk APM, you can see that I typically like to start when I troubleshoot in any case with the dynamic service map. You can see here in the past 15 minutes, and let me actually just break this down here to this environment right here for the last 12 hours so we can have a little bit more data populated. You can see here, these are all of the different microservices that are running within Kubernetes, right? You can easily go to the dynamic service map here and easily see all of the dependencies that are associated with, like, let's say the front end service. So you have the front end service, which communicates with, of course, the cart service, which is associated to the Redis cart. And then, of course, the front end service associated to a currency service, which of course is going to allow us to convert different currencies. I like paying in euro. I'm kidding. I'm just, of course, going to pay in whatever country I'm in, the currency of whatever country I'm in. But in the event that our end users visiting this site, we leverage that currency service to, of course, convert the actual dollar amount for that given end user. And so on and so forth. So you can see quickly all of the dependencies that are associated here. And then in addition to that, you can quickly click on these particular services and get the information and just dive right into the traces that easily tell you all of what we need to know about this particular service and change the duration as
And we
well as
also
go ahead
we didn't have to define the service map, right? Like APM does
at
it for
all.
you. It figures out where the connections are. That's again one of the key advantages of distributed tracing is, based on the trace ID and time, like we can tell, okay, well,
Yep.
this got handled by these services in this order. So we didn't have to define that. If the infrastructure changes, we don't have to go back and edit the map. Like the map is always up to date based on what's actually happening with our requests. And a lot of people that have maps, their map does not do that. So just keep that in
No.
mind. The automatic updating map is a really big feature for us.
Absolutely, and I can't agree more. And one of the things that I will emphasize, and hopefully we can get this to work, because I do want to say that in some cases with demos, when we put these together. So what I'm going to do is I'm going to break one of these microservices here, and this here happens to be this movie microservice dashboard that I put together, and you can see that I quickly, or sorry, not me per se, but more so Splunk APM here quickly put together some of the dependencies that are associated with this dashboard that's actually pulling information from the director microservice, the movies microservice, and the actors microservice. And you can see that information, our red metrics is actually actively coming in here With Tag Spotlight, we get a quick overview and we get information about that new downtime that Greg and I were talking about, which is of course the latency behind all of these calls that you see coming here. And if you add tags to your environment, which you can configure within the within the OpenTelemetry collector, you can add these tags. You can easily also filter by these tags. One way I like to filter things by is by version number. Let's say I want to see everything that's going on with version 1.0.1 of this given microservice. We can easily see how these particular microservices are behaving. When it comes to latency, we can see our P99, 90, and 50. And of course, we can see any request errors that may have come in. And it looks like we got one right here. So what I'll do is let's break the director's service. I'll just hit this and stop this automated script that's essentially just pulling data. And we'll see that eventually this information here will populate within Splunk APM, kind of showing the errors. And this is exactly what this looks like. And we can actually hone in into a specific error time frame where we can actually dig down and see how many errors to these specific get requests or sorry calls, this simple get request that we've completed has occurred. So we've obviously in this particular time frame have done 181 calls and only one of them have failed, right? For this particular service.
Yeah,
Anything in
and
particular, Greg, you wanted to add?
yeah, just if you look at this right now, you're kind of probably thinking, okay, so what? The real thing that's unique here is like if this service was busier and we had also a blue deployment and we also had posts and we also had usernames and other things that were tagged, you could just select the time there were problems and see what was going on broken down by those tags, right? So like you don't have
Absolutely.
to know, oh, I care about what version is running. You can just go, oh, let me look at these errors. And then you'll see in that, third box on the bottom row, like it'll show you all the versions that we're running and you'll be able to see the statistics by that version, right? And then you can do the same thing for any other tag. So you can do it by user ID, by value, by AZ host type, any of those sort of things. So like this feature can, again, it just takes all the fun out of troubleshooting because it tells
Yep.
you right there what's broken and what's wrong. So like if you really think about what are all the dimensions where things can break, this is a great way to see all at once. These are the various things that could be contributing to, my performance issue or my bug or whatever. So just, there's only one dimension for all of these tags right now, but in a real deployment, obviously the value would be that you have those multiple dimensions and you can see them all in one place. We call this tag spotlight. It's really powerful to look at what's going on broken down by those tags across your entire infrastructure.
And those are all great points, Greg. Now let's take a look at our service map here, and we could see that we are actually experiencing some errors with the dashboard. We could see that dynamically update, and we actually do provide you down here with a pretty cool little legend where we can actually kind of understand what's going on here. We can easily see these lines reflect the request, whether there's fewer requests, more requests, or less requests. And again, it's just very simple and easy to break down. And here as well, if we want to break things down by microservice and we just want to narrow things down from the actors microservice or the directors microservice and see what's going on, we can easily do that. And of course, we are only doing HTTP GET requests, but we can quickly see, something's happened here in a simple overview that we're no longer sending these simple requests. We can go back into Tag Spotlight and we can see that those requests have absolutely gone down. We're no longer able to get those requests. So definitely something is going on here. So this is again a simple breakthrough, a breakdown of what it looks like just to again leverage OpenTelemetry, leverage observability, and really just narrow down that needle in a haystack. So again, simplicity at its best. Anything you want to add, Greg?
Yeah, I think just one other thing you can look at if you click latency there at the top, like you also see
Yep.
like, oh, we had this latency was around whatever it was around and then it fell through the floor, which, normally would be a cause for celebration. but if you figured a load balancer, right, you learn pretty quickly not to do lowest response time as your load balancing method because a broken service can send to 500 really fast. So
Oh yeah.
it's just, another way you can see the problem, right, is like even if you weren't looking for errors, right, you can see just from looking at that graph, whoa, something has changed. And we don't have time to demonstrate it, but we can set up alerts based on significant changes to metrics, right? So we could have an alert set up that says, hey, the latency has drifted out of this normal window it's in, right? And it can automatically alert and say, hey, the latency is too low, right? The service is performing
Yep.
too well. Something needs to be looked at, right? And so, yeah, like Jonathan's walking through the alert setup wizard. And one of the things that I think is crazy about
Good.
this alert wizard is LinkedIn had a really advanced home-built alerting system called Ngraphs, and it also did alerts, but it was still just called Ngraphs. But anyway, when you were creating those alerts, you couldn't see what that alert would look like in the past, right? And one of the things that we can really let you do here is as you go to create an alert and you specify what the condition is for the alert, it will tell
Mhm.
you, hey, this alert over the past 24 hours would have gone off this many times. And you can change the time to say, like, hey, over the last month, right, how many times would this alert have gone off? So before you make some noisy, terrible alert, right, like this, as you're building it, will tell you, hey, this alert was going to suck, right? Like it's going to go
Yep.
off too much. There's going to be too many things going on. But there's so many possibilities in our alerting infrastructure that I had to mention that. If you respond to alerts, a high quality alert is vital, right? It's just something that you have to be able to look at and immediately know the problem, right? And so this is just a really powerful way to tell you, like, we have a sudden change alert there, right? Which will tell you, hey, this used to normally hover around here. Now it's not in either direction. So you can figure out what's going on, right? But yeah, obviously we have triggers, querying. You can simulate, when the problems will happen. You can look at all of the events where it would have gone off. As you create an alert, if there is a situation where it would have gone off, it draws a little triangle underneath. And then, if you see 300 red triangles, you're like, okay, I should
Yeah.
probably tweak some of this, right? But it's something that's really vital. And like, our observability platform, we really just talked about APM here in the demo because that's probably like the flagship observability product is being able to see what's going on. But there's other stuff as well, right? And I think one of the things that you sort of can advance your observability practice with is using things like synthetics and Rum. I don't know if you have a synthetics demo prepared, Jonathan. I'm throwing
I
you on the
do
spot with
not.
that, but like, one of the things that you can do with synthetics is to say, hey, like I'm running a shopping site, right? And I want to make sure that my customers can purchase my product. And even if my product isn't purchased all the time, right? You're not yet at the lucky position of having, one transaction per minute, even, or hour, right? Depending on what you're selling, right? But with synthetics, you can create transactions as often as you want from whatever place around the world you want. And you can actually see what the user's browsers looked like. You can see how it rendered in the how your third-party assets render, that sort of thing. And then you can also extend that with Rum, right, which is where the dashboard right
Exactly.
now, right? So like for your actual users that do complete purchases or that do come to your site, you can see in either their web browser or on their phone, right, with iOS or Android, support just added recently, you can sort of see like what is happening with those users. And I think that's really important because if you think about how web applications used to be, right, you would click on it, you would click on a thing, it would load another page. The server did all the work. It would send the client another page. That's not the case now, right? Like nobody does multi-page applications, right? It's all a single page app. So the browser is responsible for making backend requests through Ajax, right, that send data. And if those requests fail, if they're pulling in some third-party asset, if your JavaScript frameworks, or if you're using Angular or something and you don't host that yourself, if any of those things go wrong, there are reporting mechanisms built into browsers, but those might not work. They might be blocked. You might have some privacy conscious user, whatever. But there's also some situations where, the framework loaded, but for some reason the initialization didn't complete, or the user's browser barfed on some line of JavaScript due to a bit flip or something. There's all kinds of problems that can happen that make your users have a bad experience. And with Rum or with synthetics, you can see like this is what happened, right? This did not load successfully. This caused this problem for this user. So it's like if you feel like, oh, I've already done APM, I don't need to do anything else. There's always more stuff you can do. But one of the things that is really valuable to think about is instrumenting your users' browsers and phones to see what they see, right? And you can get a screenshot of like, hey, well, not a screenshot per se, right? You get an example of what it would have looked like, which really helps. So, I just wanted to talk about that a little bit. If you have any questions, we have a couple of minutes where, we can address some questions. But, that was the scripted content as it was, right? Was to sort of show you the demo, but would love to hear if anybody has any questions from any of the platforms, right? We're happy to address anything about observability or OpenTelemetry.
One more thing, Greg, before we do move on to questions, is also related content that I did want to touch on. Again, we're looking at the movies microservice here, or we can dig at the actors microservice and so on and so forth. But the cool thing about it is down here, you'll see that there is actually related content that we can leverage, and we can actually dig more into this particular host. So say for an example, we want to take a look at the movies microservice and we are seeing some type of an issue, related metrics will automatically pop up. You think that maybe this is associated to the host, we can click on host and this will automatically take us to the host that's associated with that microservice. That's also one thing I did want to add with respect to the demo before we wrapped it up for questions.
Yeah, for sure. Again, like when it's the middle of the night, you're trying to figure out what's going on. Anything that helps speed your time to finding the problem is going to help. So yeah, I mean, if anybody has any questions, please reach out to us. We are here for a little bit. And if not, we hope you enjoy the rest of your time with Splunk.tv. We have a lot more content today. If you haven't stopped by Splunk.conf, register and join us there. It's free. And there's a lot of great sessions about observability there as well. So
can I also add that there's a lot of cool prizes as well? And Greg, I don't know about you, but I'm a huge VR fan. Huge VR fan. You want to tell the audience how they can win an awesome VR headset?
I would love to tell the audience how they can win an awesome VR headset. So we have prepared a game called Pipestorm that is a way for you to create a data pipeline with OpenTelemetry. So it's educational, but it's fun still, where you get to learn about what the different components of OpenTelemetry are. So you know how to put together a collector, a processor, an exporter, that sort of thing, right? And you can play it yourself at pipestorm.splunk.com. If you are within the 50 United States, you will get a free t-shirt for completing the game and can enter to win an Oculus Quest 2 is the prize for this cycle. And it's super interesting to get to just see how these parts fit together. It's a lot of fun. So we would love for you to check that out.
Well, the powers that be are telling me that I believe we have 1 minute left. So with that, I encourage you guys to definitely play this game and do some observability in virtual reality. The next demo, I promise, will be in virtual reality.
And if you want to learn more about observability in general, right, splunk.com/the letter O, the number 11, and the letter Y. It's a cute abbreviation for Ollie. We've got some more resources for you there. Thanks so much for your time today. We hope you really enjoyed it.
Thanks, everyone.